This is Module 1, Lesson 1, an introduction to signed numbers, absolute value, and operations with integers. First, we need to look at some vocabulary. The natural numbers are the set of numbers 1, 2, 3, 4, etc. I like to think of these numbers as the numbers that you naturally count with. If I was going to count the number of apples that I have, I would say I have 1 apple, then 2 apples, then 3 apples, etc. I wouldn't naturally start counting with 0. Now the whole numbers do include 0. These are the set of numbers 0, 1, 2, 3, 4, etc. Then we have the integers. Those are the negative and positive whole numbers. So negative 3, negative 2, negative 1, 0, 1, 2, 3, etc. And then lastly, we have the rational numbers. These are numbers that can be written in the form of an integer divided by a natural number. In other words, you can think of the rational numbers as the set of numbers that can be written in the form of a fraction. Now it's important to note that these sets of numbers are all contained within one another as we move down this list. So what I mean by this, if we start off with the set of rational numbers, so I'll go ahead and label this rational. Within the set of rational numbers, I can fully contain the set of integers. So we'll go ahead and call this set the integers. So what I mean here is that all integers are also classified as rational numbers. All negative and positive whole numbers could be written in the form of a fraction simply by putting them over a denominator of 1. Well then further, within the set of integers, I can then fully contain the set of whole numbers. And then furthermore, within the set of whole numbers, I could fully contain the set of natural numbers. So natural numbers are classified as whole numbers, which are also classified as integers, which are also classified as rational numbers. Now we have one more definition. The absolute value of a number is the distance on the number line between that number and 0. So for example, if I want to look at the absolute value of negative 6, I need to look at how far negative 6 is from 0 on the number line. Well, negative 6 is a total of 6 units from 0, therefore the absolute value of negative 6 is positive 6. Similarly, if I look at positive 6, well, positive 6 is also a total of 6 units from 0, therefore the absolute value of positive 6 is also 6. Now let's look at a few examples. We want to graph the following numbers on the number line and state the most specific classification of each number in the set. So looking at this set, our numbers are ranging between negative 4 and 2/3 and positive 1 and 2/3. So to make sure I have enough room for all of these numbers, I'm going to start labeling my number line down at negative 5. Now, to be able to draw a negative 4 and 2/3, I need to recognize that that's more negative than negative 4, meaning it's to the left of it. So I'll just put little tick marks for divisions by 3 so that I can identify that negative 4 and 2/3 is the second tick mark. Now, in order to classify this, I need to identify which set it's in. Well, negative 4 and 2/3 certainly is a rational number since it's in the form of a fraction. I could further rewrite this as an integer divided by a natural number by changing it from a mixed number to an improper fraction. Well then I need to ask myself if I could further classify this in a smaller set, such as the integers. Well, the integers are the negative and positive whole numbers, and since we have this fractional part here, it can't be further classified as an integer, therefore the most specific classification I can give this is a rational number. Now we want to label negative 3. Well, we already have negative 3 on our number line. To classify this, I should first recognize that negative 3 is in fact a rational number because it can be written as negative 3 divided by 1. Furthermore, it is an integer, it's a negative or positive whole number. But I can't go the one step further to whole number since it does have that negative. So the most specific classification for negative 3 would be integer. Now for negative 1. Well, we do also have that already labeled on our number line. As far as its classification, it will be similarly classified as that negative 3 as an integer. It cannot be further classified as a whole number. Then for 0, well, we have that right here. 0 certainly is a rational number, as it can be written as 0 divided by 1. It certainly is an integer, and furthermore it is a whole number, as the whole numbers start at 0. But I can't go further to the natural numbers, so the most specific classification of 0 would be whole. Lastly, for 1 2/3, I'm going to give myself some tick marks between the 1 and 2 so that I can see third divisions. And then I'll label this second tick mark right here as 1 2/3. Now similarly to negative 4 2/3, the most specific classification I can give here would be rational. Now for example 2. We want to insert the greater than, less than, or equal to symbols to make the statement true. Well, I'm looking at 88 versus negative 12. Clearly 88 is greater than negative 12, so I'll use the greater than symbol. I like to remember which one is greater than or less than by thinking of it as a Pac-Man, and Pac-Man always eats the bigger number. So since 88 is greater than negative 12, the mouth needs to open up towards that 88. Lastly, for example 3, I want to find the absolute value of negative 5. Well, looking on a number line here, I can see that negative 5 is a total of 5 units from 0. Therefore, the absolute value of negative 5 is 5. Now let's look at adding integers. When we add integers, it's important to pay attention to the sign of the numbers. If the signs are the same, we'll add the absolute values of the numbers and keep the sign. If the signs are different, we'll subtract the absolute value of the numbers and keep the sign of the number with the bigger absolute value. It's often helpful to think about money while we're adding integers. A positive number means you have money, whereas a negative number means you owe the money. So let's look at an example. Negative 11 plus negative 9. They are the same sign, they're both negatives. We owe $11 and we also owe $9. So we'll add the absolute values of the numbers, meaning I'm adding 11 plus 9, which gives me 20. And I keep the sign, I owe $20. For part B now, I have 11 plus negative 9. This is saying I have $11 and I owe $9. So I'll actually subtract these numbers. 11 minus 9 is 2, and I'll keep the sign of the larger number, the 11. Therefore, I have $2, which should make sense. I started with 11, I owe 9, I'm left over with 2. Now on to subtracting of integers. When we subtract, it's the same thing as adding the opposites. So what we'll do is we'll change the subtraction problem to an addition problem, and then we'll add as above. So for example, we see that 3 minus 2, we know that's 1. That's the same thing as saying I have 3 plus a negative 2. We add the opposite. In general, we can say that a minus b is a plus a negative b. So we're going to subtract the following numbers by first changing the subtraction problem to addition and then using the rules of addition above. So I have 4 minus negative 5. Well, we can say that we add the opposite, so I keep the 4, I change the middle subtraction to addition, and the opposite of negative 5 is positive 5. So 4 minus a negative 5 is equivalent to 4 plus 5, which is 9. Now for part B, I have 6 minus 7. So here I want to add the opposite, so that means I'm keeping that 6, I'm changing the middle subtraction to addition, and the opposite of positive 7 is negative 7. So you see I've changed both middle signs. Now I have an addition problem with opposite signed numbers, so I really want to subtract the numbers. 7 minus 6 is 1. I'm going to then keep the sign of the 7 because it's larger, so we're saying that 6 plus a negative 7 is negative 1, which should make sense because it's like saying I had $6, I owe $7, so I'm left over owing $1 still. Now we're on to multiplication and division of integers. When multiplying or dividing integers, if the signs of the two numbers are different, then the result will be negative. Why is this true? Well, let's think. If I have a positive number that I multiply by a negative number, that negative number that I'm multiplying essentially takes the opposite of our product, which gives me a negative outcome. Similarly, if I have a negative number times a positive number, my result will also be negative because once again, that negative number takes the opposite of our product. Similarly, of course, with division. Now, if I have two numbers of the same sign, for example, I have a positive times a positive, well, you can see since they were both originally positive, there is no chance of negating the answer, so the answer is positive. Well, if they were both negative, negative times negative, this is saying I'm taking a double opposite. So the opposite of a positive number is a negative, but then the opposite of a negative number is back to positive. So let's look at a couple examples. I want to multiply negative 15 times 5. So I already know that my result, my product, should be a negative because I have opposite signed numbers. As far as what the actual product is, well, I'm going to set up that I have 15 times 5. I know 5 times 5 is 25, carry the 2. 5 times 1 is 5, plus 2 is 7, so I end up with negative 75 here. Now, to divide negative 45 by negative 5, since the signs are the same, I know my result is positive, and 45 divided by 5 is 9. Okay, lastly, true or false? The sum of a positive number and a negative number is always negative. Well, it's often helpful to think through some examples to make our decision. So let's say I have positive 5 and I'm adding to that negative 7. Well, this does appear to come out negative. We know when adding opposite signs, I actually subtract. 7 minus 5 is 2, and I take the absolute value of the larger number. So I take that negative from the 7. So that does look like it came out negative. But now let's switch the signs. We're saying let's take positive 7 and negative 5. Well, again, 7 plus negative 5, I subtract because they're opposite signs, I get a 2. But now I take the positive sign because the 7, the larger number, is positive. So this seems to make the statement false. Since we're able to find one occasion where the statement was false, overall, we'll say it's false. So remember, when adding integers, we'll always take the sign of the number that has the larger absolute value.